Just a young gun with a quick fuse. I was up.
Alright, continues with the next part 2. Okay, for the chapter 2 we have, such as right now the learning outcome, we have calculate the photon of energy emitted by an electron that produce a particular wavelength during transition using the formula delta E H view. Perform calculations involving the Ribot equation. So in this topic, we have character of wavelength, we have character of frequency. Okay, so take a look at the example question by previous example PSPM. Alright, so a line with a wavelength of 486.4 nanometer was observed in the Balmer series of emission spectrum of hydrogen. Calculate its frequency, determine value of energy level. And last one state the region of electromagnetic spectrum, which the line found. Using the formula directly, v equal to c over lambda, speed of light, which is have 3.00 times 10 power of 8 divided with lambda, we have 6.17 times 10 power of 14, the unit per second or hertz. The second, using formula Ribot equation, 1 over lambda equal to RH, 1 n square and 1 square minus with n2 square, which is n1 elevate the lowest number because wavelength was positive value. Alright, so replacement with the data in the formula, okay, using 1.097 times 10 power of 7, okay, in unit for RH meter. Alright, and then equal to K 4, in this case 4. So at the same time, for Balmer series or the emission drop in n equal to 2, that one represented by visible spatial region. Okay, so next one, calculate. You also can consider calculate ionization energy for hydrogen atom for Lyman series. So based on this diagram, you can discuss. When the emission drop n equal to 1, this one considered by Lyman series. Lyman series n equal to 1. The emission drop to n equal to 1. If drop n equal to 3, we have a Perkongsian series, and Balmer series, okay, drop to n equal to 2, the emission, but absorption, they move to the higher energy, they absorb to a certain level. Alright, okay, so we take a look the highlight for diagram, just sharing the tip. If you have a question about diagram must be labeled, draw big and clear diagram, right? Okay, in this we need to draw energy level diagram to show all possible line produced when all these electrons drop to lower energy, and also identify the line which have a shorter wavelength. So the idea for the excited electron of a group, which is have related by n equal to 1, 2, 3, and 4 energy level. So, and we need to sketch the diagram with energy level n equal to 1, 2, 3, and 4. So maximum n equal to 4 as energy level. The maximum line for n equal to 1, we have 1, 2, 3 line. Okay. For n equal to 2, transition between 3, 2, 4, 2. So maximum 2 line. So the transition between 4, 3. So just maximum 1 line. Okay. And then the line of shorter wavelength, which is transition for n equal to 4 to n equal to 1. Higher energy, shorter wavelength. Alright. So for next one, if you try to explain relate by learning outcome, we want to relate by Arbor principle, Hans rule, Pauli exclusion principle, and then we also try to predict the electronic configuration, atom, monoatomic ion. We have both SPDF notation, orbital diagram. Okay, and last one, we have anomalous electronic configuration of copper and chromium for chapter 2. Okay, take a look at the example question. This one also the previous PSPM example question. Okay, atom X. We have ion of atom X have 8 outermost electron and 10 inner electron which have charge -1. Discuss all the rules and principles used to fill the electron in the orbital of X. First, okay, what the total number of electron of atom X? Okay, take a look. X have 10 inner plus 8, so 18. This one ion reduced by 1 because -1, so the total number of electrons should be 17. Alright, so according by 17, we follow the rule to write the SPDF notation. Alright, we have 1s2, 2s2, 2p6, 3s2, 3p5, so 17. Alright, so followed by the lowest energy to the higher energies level, according by our Bohr principle, alright, increasing order of orbital energy level. And also can mention the increasing order of energy 1s, followed by 2s, followed by 3s, and followed by 3p. Cancel number of 2, this one, yeah. Relate by Hans rule, okay. We have the term parallel spin, mention the parallel spin, and mention the degenerate orbital, okay, simply before pairing, alright. And last one, relate also to finish the electron, okay, by the same orbital must be opposite spin. Yeah. Two electrons may occupy the same atomic orbital. This electron must have opposite spin. Alright, that's all. Let's continue with next part. Thank you.
Just a young gun with a quick fuse. I was uptight.